Over here, we have a trolley that has a mass of 25 kg being pushed up a shopping center ramp. Now, I'm just going to draw out some of the details here. So we got, first of all, let's draw ourselves a ramp. And it's got an angle of 16 degrees. From the horizontal, we got a trolley. Now, not really an artist, so I'm just going to draw this as a block. This is my trolley over here. And I want a net acceleration of 2 meters per second squared parallel to the ramp. I'm just assuming that it is parallel to the ramp, because if it's not, then we're going to say the trolley is accelerating off the ramp, which is flying off. Probably not going to assume that, or it's sinking into the ramp, and that requires a bit of force. So I'm not going to assume either of those cases. So over here, there's a few things happening. First of all, I'll need to find out what the net pushing force is up the ramp to accelerate at this pace. So over here, there's a pushing force. Of course, I could draw on the other side of the trolley as well. It's a vector, it doesn't really matter where it starts. I'm just going to put it on the underside of the trolley just to get a feel of this force pushing up the trolley. And I also have a frictional force. Now, since I drew this arrow into the trolley, I'm going to just draw my small frictional force here going in the opposite direction of motion. So if the trolley is moving upward, then my frictional force here should be going in the opposite direction. So this is 20 newtons. We don't know what the pushing force is. That's it. That is our objective. And for our force analysis, there is a little bit more, and that is the weight force. I'm not sure what this is or how big it is, but for now, I'm just going to say this is our weight. This is mg, and it's going directly down. So before we keep going, let's draw a quick axis. So this axis is just telling us which way is horizontal, which way is vertical. So x being parallel to the ramp, y being perpendicular to the ramp, and going up the ramp is positive, going down the ramp is negative. Okay, so over here, if I want to find acceleration in the x direction, so this is acceleration in x, then I obviously want to sum the forces in the x direction. So we can do that. Okay. First of all, what forces are going in the x direction? This is pushing force. There's a frictional force. There is also this mg over here, our weight force. But hang on a sec, it's not going in the direction of either of these axes. So what we need to do is split it up into two parts. So this is mg, and let's split this up into two vectors that are, actually, that could be a little bit better. I'm just going to Control Z this a little bit. So two vectors which are parallel to both these axes. So first of all, parallel to the y-axis, kind of like that, and parallel to the x-axis. Oh, that's good enough. Good enough for me at least. Okay. So we know this angle up here is 16 degrees, equal to the inclination of the ramp. So if this is 16, then when we draw our forces, we know this one is mg cos theta. It is the adjacent side to this angle. This is mg sine theta, because it is the side opposite to the angle. So from here, maybe we'll scroll down a little bit, give ourselves a bit of room. We can start using Newton's second law in the x direction. So you can say in the x direction, or you can say the sum of forces in the x, just use a subscript there, and say that this is equal to mass times acceleration. Okay, so over here, what we have is a pushing force going up the ramp, so Fp is positive. This frictional force is opposing that pushing force, or in other words, it is in the negative x direction. This mg sine theta, now, of course, the weight of the trolley isn't actually doing you any favors in pushing it up. In fact, it's hindering you. So, and you can also see that this arrow is going down the ramp. So this means that we're subtracting by mg sine theta. And this is all equal to the mass times acceleration. So from here we can sub in all of our numbers, except for pushing force, because that's what we want to find. Fp minus 20 newtons for friction. The mass of the trolley was 25. We're going to let G equal to 9.8. Our theta was 16 degrees. And this is equal to mass times acceleration. And the acceleration that we wanted was 2 meters per second squared up the ramp. Let's just double check. Yep, here it is. Okay, and we go back down over here, finish our calculation. So we can say that Fp, our pushing force, is equal to, we have 50 over here. I'm going to chuck this 20 to the other side. And chuck this entire term, 25 times 9.8 times sine 16 degrees. Okay, let's see what we get over here. So we have 70 over here. Let's bring out a calculator. Where is my calc? Here it is. So we have 70 plus 25 multiplied by 9.8 multiplied by 16 degrees. Now my calculator is in radians, so sorry about this, but I'm just going to do my quick radian conversion here into degrees. And here we have 137.5 to 1 decimal place. So this is the amount of force that we need to push up the ramp. And it makes sense that this is a positive value because our pushing force here is going up the ramp. So naturally we need force in the positive x direction. So that checks out.